All right, this is Emmanuel Cartier, and he'll be talking about a web platform for neologism tracking.
Hello, thank you. So I will talk about an ongoing project, Neovei, a web platform for neology tracking. So I will talk about some elements of motivations, and I will present the Neovei project, and I will focus afterwards on first experiments we've made on semantic neologism detection, and then I will conclude. So as for the motivation of this project, we would like to provide a tool for linguists with the following features. So corpus management, neologisms linguistic description and management, and also a bunch of automatic tools for automatic retrieval and storage of corpora, automatic detection of neologisms, either formal or semantic, and also some tools to track the life cycle of these neologisms. And in any way, an important point is that we always give the last word to the linguistic decision. It has also a multilingual purpose and an high availability via a web-based platform. So Neovei was an NR-funded research project gathering 7 research centers, 3 French teams and 1 team per other languages. It uses a corpus-based approach which combines also computational linguistic and human expertise. It is available with a public part and a private part for editing, in fact, the data at the following address. So I will present now the main components of the platform. That is the corpus manager, the automatic analysis of articles and its storage, and automatic detection of neologisms, the manual validation of candidate neologisms, and the neologisms manager, and also the tools to track the life cycle of neologisms. So here you can see the main one of the interface of the corpus manager. So we have the basic functionalities: add, read, edit, delete, search. So every source of information that a linguistic user can add can be also, you can also add some metadata about the domain, for example, or diatopic information. If, for example, for French, you have some varieties from all over the world. So at the moment, we work with RSS feeds. So once the RSS feeds are entered by the user, every source of information, the RSS feeds, are automatically retrieved twice a day. The articles themselves are retrieved, then post-tagged and stored in a search engine. And afterwards, the specific module detects the candidate formal neologisms. So this is some figures of this module. So you can see the distributions of RSS feeds by language and the number of articles retrieved as for now. So you can see that French is the most advanced corpora in this way. So afterwards, you have a formal neologisms detection, automatic detections, which use what is called the dictionary, the exclusion dictionary methods. That is, you define an initial dictionary with words that you consider pertaining to the usage at a given period. And then when you check for every word in your monitor corpora, new words, and then you add also some filters to get out spelling mistake, proper names, and citations. So it is a recursive process as, in fact, the candidate neologisms through this automatic process are presented to the user. You have an example here. And then afterwards, the linguist choose, okay, this is a candidate, a true neologisms, or it is not. And afterwards, if you say not to a given word, this is stored in an exclusion dictionary, and it's never retrieved afterwards. So at the moment, we have between 100 and 200 candidate neologisms per day, among which about 60% are true neologisms. So in a lot of cases, you have some problems to decide if it is a true neologisms. Our consumption is a neologisms is directly from the first emergence, the first occurrence. But from time to time, it's difficult to say, okay, it is pertaining to the dictionary or it is a neologism. So you have tools just to see, for example, the occurrences, as you see at the top of this page. And here you have a kind of synthesis, statistical synthesis, with a timeline of the occurrences, and also diastatic information, for example, the distributions per country, the distribution per domain, and the distribution per newspaper. So the following module, once the linguistic expert has validated the neologisms, is to describe them linguistically. So you have another module to do that. I will not get into details of that, but you have some generic information. This is on the left part, and also specific information to detect what kind of mechanisms triggers the neologisms. And finally, the last module is the life cycle tracking of neologisms. So you have the same interface as I saw a minute before. So you can check how a neologisms evolves through time, and if it disappears, as in fact about 90% of neologisms disappears in the 2 or 3 months after their first appearance, or if they disseminate, and we will see in the future, but not for now, if they can be lexicalized for specific neologisms. So now I speak about, I focus on semantic neologisms, so it's much more difficult, apparently, than formal neologisms. As you traditionally, we consider semantic neology to have no formal counterpart, so no cue to detect them, whereas formal neology is defined as having a formal part. But in fact, it is just the way you consider the formal part that explains this distinction, because we can hypothesize that every new meaning has a formal counterpart, either on the internal form of the word, this is formal neologisms, but also for semantic neologisms, about his usage, his usage change. So this is the hypothesis we ground on. So we investigated 4 means to detect semantic change. So first, normalized frequency change. Why not? After all, this is the first information we have. Second, co-occurrences in a broad sense, inspired by word sketch, evidently, but also variants of that, that is combinatorial profile or behavioral profile as defined by Greece. We also experimented with the semantic distribution change, that is word embeddings, which is grounded on the second-order Harris hypothesis that words sharing the most of context are most likely to be semantically related. And in this, with this procedure, you can detect synonyms, but not always. We will see not just synonyms, but you can retrieve synonyms of a given word and then compare the synonyms from one period to another. And we will also, as we have this information, use diastatic and diatopic information. So an example of frequency change. So here we have compared for French two periods from Le Monde, one from the 90s and one other nowadays, in fact, with what we have retrieved in the Neologism project. And what you can see, it is an example of rising, a steep rising of words. So you have effectively Courriel, ex-URSS, and so on. So what is our interim conclusions about the use of frequency change? First, this is naive, okay? But in fact, it is a relevant approach for steep change. Because you can detect novel and obsolete objects. The example of appearance is Courriel, email, and so on. And also the disappearance of elements, for example, Minitel or video text, which was used 20 or 30 years ago, but is not yet used. You can also detect, in fact, a change in the semantic space, in the lexical fields. For example, in French, you have, in the 90s, you have a lot of examples of the verb inculper, to charge. And there was a law distinguishing two concepts at the beginning of the century, between to charge and between to put under an investigation. And so now, inculper has fallen in use, has steeply followed, is quasi not existing now, whereas it is replaced by mettre en examen, which is the official name for putting under investigations. So one requirement, but it is true for all methods, it is that you have to have a representative corpus, and also that you have you need a kind of large time span to detect interesting things. At the beginning, we just tried to use our Neologism corpus from 2015, but it was not enough to detect interesting elements. But a problem with that technique is that you can't, you can detect steep rise or steep fall, but you can't detect all the rest. So the second experiment that we made was to detect a combinatorial change in for lexical unit. So we take a corpora with Google Ngrams for the first period from the last century up to the beginning of the current century, and we take a more recent corpora from Le Monde and Neologism. We tagged it with lemma and pos, and we follow two steps. First step, for every lexical unit, we get every 1 to 5 grams with the information with the lexico-syntactical patterns, and we get its relative frequency. And then we filter the syntactic constructions to see what are the most used syntactic constructions, and then for them, so we can compare just the syntactic construction, and then when we have similar constructions, identical construction, we can check the lexical units pertaining to given constructions. So I will not enter into the details of the measures. This is an example of that with tsunami, which is known all over the world. It's come from the Japanese. So the first occurrences are at the beginning of the last century with a specific meaning, which is the tidal wave, in fact, something like that. But specific for Japanese, this is a seismic in fact, tidal wave. It is a kind of eponyms of tidal wave. And we see here examples of its usage. And you see here that it rises. But if you focus between 2000 and now, you have a steep rise here. You have a huge steep rise. And what is going on at that moment? You know that a tsunami with a tidal wave in 24 was again rising with this event. But in French, we have other uses that appeared. First, we have a lexical field replacement because in French now, tsunami and raz-de-marée are in fact a kind in concurrence, first. Second, you have a lot of metaphorical usage based on the feature of the concrete object, violent and sudden event. So you have, for example, a social tsunami or a political tsunami, etc. And you have also a novel usage, which is as a complex determiner, a tsunami of something. So you can, in fact, detect these changes. Here you have the syntactic constructions in the first period. So you have adjective with specific adjectives. You have also a verb usage with verbs referring to a destruction, in fact, mostly, or trigger. And in the last period, you have also the same syntactic constructions, but here with the adjectives, you have different novel adjectives appearing. And as for the verbs, it is always the same. The same because, in fact, the feature that is preserved for the changing is the fact that it is sudden and violent. And you have also a novel system, Tsunami 2. So, as a conclusion on that, the combinatorial profile able to track changes in usage avec two main characteristics. First, the productivity of specific syntactic patterns, and second, the entrenchment of specific constructions detected by attraction in the given syntactic patterns. So you have also some bottlenecks because it's, in fact, when you have a lot of corpora, really hard to detect only the canonical constructions, as I presented to you. You have a lot of what Harris called the reduction constraints, which means that you have pronouns, you have implicit places, and all that. So I will just show you in a minute, as an example, what I've done Hamilton on the similarity approach, what it has done for English. So it can explain, for example, how gay change its meaning from sweet, cheerful, tasteful to bisexual, homosexual, lesbian. And you have also other examples. This is another approach. The main problem of this approach at the moment is that you can detect, and it is really accurate, you can detect the similarity, the semantic similarity, but behind this similarity, you can have, that's great, synonyms, hyperonyms, eponyms, but also a lot of other semantic relations. So to conclude, so this project is ongoing, and it's available online. So in fact, adding a new language is just a few steps forward. You can check it. So now, in a recent, we will have an English version soon. And there is a public part that where you can check and and play with the data. So as for formal neologisms detections, it's currently working with a relatively efficient recursive dual system, combining automatic detection and human decision. The life cycle tracking systems also is really pretty to use. And as for semantic neology detection, we will put some results, some global results at the end of the year. That's it. Thank you.
Great presentation. Any questions? Anyone?
With the semantic neology detection, as you rightfully pointed out, if you use these word embedding approaches, you get all kinds of relations. But would that be something that you're interested to characterize the type of semantic extension, whether it's metonymic, metaphoric, that a new meaning instantiates?
Yes, you mean how can we detect more specifically the semantic relations?
Yes.
It is a...
The tsunami is metaphorical,
Yeah.
I guess. So
Yeah. But in fact, as for tsunami is concerned, you can detect it directly, not with similarity distributions, but with the co-occurrences, because it is you can see it in the distributions. Whereas for semantic similarity, it is really it is harder because the principle is to detect words sharing other words, so they are never in the same context. So it is a second order. So it's hard. It's in computational linguistics. It is a big track of research to go from semantic similarity to semantic relations, in fact.
All right, I think we have time for one more question. Anyone else have any questions? All right, I have a question. No one else? Okay. So you said that 90% of neologisms disappear within 3 months. Is that right? So I was curious about the other 10%. What are some qualities that make a neologism stick around?
But as for the 10% remaining, in fact, we can't, for now, say anything, because the project has 2 years. So for now, they're still existing. They are still existing, but we don't know effectively what they will become. I think we will have to wait more time to know if they will be lexicalized or just disseminating and then disappearing. I think there is no. I'm not sure we can have. There is models. Canonical models of life cycling of lexical units, as it is linked to socio psychological factors that are hard to modelize.
Yeah, it would be really interesting to have a predictive model for lexicographers, so we know if we should put something in a dictionary or not bother.
I'm not sure we can have a predictive models of lexical evolution, and I hope it's not possible.
Well, thank you very much. That was great.